Hi students, welcome back to the Google Classroom of Plus 1 Statistics, Chapter 6, Measures of Dispersion. Children, in the previous chapter, we have learnt about measures of central tendency as that value of the data which is capable to represent the universe. Averages simplify the complex data and make the study easy. Yet averages suffer from a great limitation that these do not give complete detail or information of the data. The actual values may differ from the average value. The average value does not reveal the variability present in the data. In this chapter, we will study about such differences or dispersion. Children, these are the deleted topics from CBSE 11th Standard Statistics, Syllabus 2020 to 21. Unit 3, Statistical Tools and Interpretation. Topics deleted, Measures of Dispersion. From this chapter, Range, Quartile Deviation, Mean Deviation, and Coefficient of Range, Coefficient of Quartile Deviation, Coefficient of Mean Deviation. These topics are deleted from this chapter. Okay. So children, take your textbook, 6th chapter, Measures of Dispersion, and you have to mark range, quartile deviation, mean deviation, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation. All these topics as deleted for this year. Okay. So children, let us start with the definition or what is dispersion. The degree to which numerical data tend to spread about an average value is called the variation or dispersion of the data. Once more, the degree to which numerical data tend to spread about an average value is called the variation or dispersion of the data. And there are two types of dispersion, absolute and relative measures of dispersion. When dispersion of the series is expressed in terms of the original unit of the series, it is called absolute measure of dispersion. Once more, give more steps to the original unit of series. Okay, when dispersion of the series is expressed in terms of the original unit of the series, it is called absolute measure of dispersion. The relative measure of dispersion expresses the variability of data in terms of some relative value or percentage. So, as the name indicates, this expresses the variability of the data in terms of some relative value or percentage. Let us move to the next topic, standard deviation. Standard deviation is the square root of the arithmetic mean of the squares of deviations of the items from their mean value. This is generally denoted by sigma of the Greek language. This symbol is used as sigma. Okay. Coefficient of standard deviation is equal to sigma divided by x bar. X bar means arithmetic mean. So what is the formula for coefficient of standard deviation? Sigma divided by x bar. Children, this is the formula for calculating standard deviation. Standard deviation, this is denoted by sigma. Standard deviation is denoted by sigma. So, sigma is equal to root of sigma x minus x bar all square divided by n. Once more, root of sigma x minus x bar square all divided by n. Here is an example. We are going to try and find the standard deviation of the minimum temperatures of 10 weather stations in Britain on a winter's day. The temperatures are 5, 9, 3, 2, 7, 9, 8, 2, 2 and 3. For this purpose, first we have to construct a table. To calculate the standard deviation, we construct a table like this. First column x, then x bar, then x minus x bar, then x minus x bar square. All these you should write in the table. Okay. Next, we have to write the given values, temperature in the column X, 5, 9, 3, 2, 7, 9, 8, 2, 2 and 3. Then calculate the sigma X. Sigma X is equal to, you have to calculate all these values, given values. We get sigma X. We get 50. By calculating all the given values, we get 50. Then x bar, the simple equation for calculating x bar arithmetic mean is equal to sigma x divided by n. So here sigma x is equal to 50 and the total number 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So total number is equal to n is equal to 10. So we have to divide 50 by 10, we get 5. So here in the x bar column, you had to write 5. Then find out x minus x bar. So we have to subtract all these two numbers, each and every numbers from this x bar. Okay, 5 minus 5 is equal to 0, 9 minus 5 is equal to 4, 3 minus 5 is equal to minus 2, like this. Okay, so 2 minus 5 is equal to minus 3, 7 minus 5 is equal to 2, 9 minus 5 is equal to 4, 8 minus 5 is equal to 3, 2 minus 5 is equal to minus 3, 2 minus 5 is equal to minus 3, 3 minus 5 is equal to minus 2. Next, you have to find out the square of all these numbers. Which number? X minus x bar. Okay, so here 0 is equal to 0 square is equal to 0, 4 square 16, 2 square 4, 3 square 9, 2 square 4, 4 square 16, 3 square 9, 3 square 9, 3 square 9 and 2 square 4. Then find out the total, that means sigma x minus x bar all square. So you have to add all these values and we get 80. Then find out sigma x minus x bar square divided by n. So 80 divided by 10, we get 8. Sigma x minus x bar square divided by n, we get 8. Then root of sigma x minus x bar square divided by n is equal to, that means root 8 is equal to 2.8. Okay, is equal to 2.8. The answer is 2.8 degrees Celsius. So children, for calculating standard deviation, first you have to write down all the given values, that means x, and find out sigma x and find out x bar, that means sigma x divided by n, that is x bar, sigma x divided by n. Then you have to write down the x bar here and find out x minus x bar. So you have to subtract the all x from the x bar. Then find out x minus x bar square. Then calculate the total, sigma x minus x bar square. Then apply all these values in our formula, sigma root of sigma x minus x bar square divided by n, and we get the answer. Next one is Lorentz curve. The measures of dispersion discussed so far give a numerical value of dispersion. A graphical measure called Lorentz curve is available for estimating inequalities in distribution. Note that point, this Lorentz curve is available for estimating inequalities of distribution. Lorentz curve uses the information expressed in a cumulative manner to indicate the degree of inequality. For example, Lorentz curve of income gives a relationship between percentage of population and its share of income in total income. It is especially useful in comparing the variability of two or more distributions by drawing two or more Lorentz curve on the same axis. So children, Lorentz curve is a measure of deviation of actual distribution from the line of equal distribution. Lorentz curve as a measure of dispersion is presently applied to the following parameters. which all parameters: distribution of income, distribution of wealth, distribution of wages, distribution of profits, distribution of production, and distribution of population. Children, please note that the corresponding notes of the lesson and test paper are also attached along with this video. Make use of all these available resources, study well, and attend the test paper without fail. Thank you.